What if I told you there's something under Antarctica that's defying everything we thought we knew about the Earth's magnetic field? Deep beneath the endless sheets of Antarctic ice, satellite scans have revealed a powerful magnetic anomaly, so vast, so intense, and so unexplainable that it's left the world's top geologists completely baffled. This isn't a glitch. This isn't a misread. This is real, and it's rewriting our understanding of what lies hidden beneath the most remote and inaccessible continent on Earth. This strange magnetic anomaly, discovered in a region known as Wilkes Land, is not a recent rumor or speculative myth. It was first detected through NASA satellite data and later confirmed through independent scientific analysis. The anomaly spans over 300 miles across, buried beneath 2 miles of solid ice, and it's generating magnetic readings that defy the geological structure we know should be there. In other words, geologists are staring at something that cannot be explained by current models of Earth's crust and mantle. Antarctica has always held a strange grip on the human imagination. Unlike any other place on Earth, it's shielded by a brutal environment, untouched landscapes, and strict international treaties that prevent full exploration. It's a place of mystery, isolation, and secrets. And now, it's the center of one of the most confounding scientific puzzles of the 21st century. The magnetic field of Earth is usually stable and predictable. But here, under Antarctica's frozen silence, we're seeing a magnetic anomaly so powerful it could be the scar of a massive asteroid impact, or something even more unusual. Some scientists believe it could be the remains of an ancient civilization buried beneath the ice. Others suggest it might be a massive, naturally occurring metallic structure that formed in Earth's deep past. Still others wonder if this could be linked to hidden magma activity or an unknown force affecting the magnetic flux of the entire region. No matter what the cause, one thing is certain: something unusual is buried under Antarctica's ice, and it's sending out magnetic signals strong enough to be seen from space. As global temperatures shift and ice begins to melt faster than ever, this anomaly is slowly coming into sharper focus, both literally and scientifically. And while science tries to catch up with this mysterious data, public curiosity is exploding. What's beneath the Wilkes Land crater? Could this anomaly be evidence of a long-lost impact that reshaped the planet? Or is it the key to something far older, deeper, and far more mysterious? In this video, we'll dive deep into the origins of this anomaly, the cutting-edge satellite technology that discovered it, and the most mind-bending theories surrounding what could be buried beneath the Antarctic ice. From shocking satellite discoveries to ancient maps and government secrets, we'll uncover the hidden story scientists won't tell you, until now. Stay with us as we explore what could be the biggest geological mystery of our time. Because once you understand what's really going on beneath Antarctica, you'll never look at our planet the same way again. Antarctica, the last unexplored frontier. Antarctica. The very name evokes a sense of cold, desolation, and distance. It's the fifth largest continent, yet the least inhabited. A place where temperatures can drop below -80 degrees Celsius, where winds howl across thousands of miles of ice, and where the sun doesn't rise for months on end during winter. But what if this frozen world, long dismissed as nothing more than an icy wasteland, is actually hiding the most significant secrets of our planet? The story of Antarctic exploration is still surprisingly young. Unlike the rest of the world, Antarctica remained untouched by human hands for most of history. The first confirmed landing didn't happen until 1895, when a team of Norwegians stepped onto its ice. That's just over a century ago. The heroic age of Antarctic exploration soon followed, with names like Roald Amundsen and Ernest Shackleton becoming legends in their race to conquer the South Pole. But even their journeys only scratched the surface, literally. Much of Antarctica remains a blank space on the map, especially beneath the miles-thick ice sheets that cover its landmass. These ice sheets, which average over a mile in thickness, have buried whatever lies below for millions of years. This vast and seemingly impenetrable cover has kept scientists guessing about what's hidden beneath. Is it simply rock and soil, or is there more: structures, impact craters, ancient terrain, or even preserved remnants of ecosystems long gone? The remoteness and danger of the continent aren't the only barriers. Antarctica is also heavily protected by international law. The Antarctic Treaty, signed in 1959 by 12 countries and now including over 50 nations, prohibits military activity, mining, and even permanent settlements. Its official purpose is to preserve Antarctica for peaceful scientific research. But the effect of this treaty has created something even more powerful: inaccessibility. Large portions of the continent are off-limits, and any exploration must be approved under strict environmental and diplomatic regulations. While this has preserved Antarctica's purity, it's also fueled decades of speculation. Why such strong global protection for a frozen desert? Why the intense regulation of who can go, what can be studied, and where research can take place? Some argue it's simply to preserve the ecosystem. Others wonder whether it's about guarding secrets, scientific, geological, or perhaps even historical, that could fundamentally change how we view the world. Despite these restrictions, Antarctica has become a scientific magnet. Research stations from around the globe operate year-round, with scientists studying everything from climate change and glaciology to astrophysics and biology. The ice cores pulled from the continent are like time capsules, holding atmospheric records from hundreds of thousands of years ago. But even these critical studies have one thing in common: they focus on the surface and what lies just beneath. Very few missions go deep, and even fewer explore the bedrock where the real anomalies lie hidden. What has captured the attention of scientists in recent decades isn't just the ice itself, but what satellites and ground-penetrating technology have started to reveal below it. Antarctica's subsurface is not uniform. In fact, it's surprisingly complex. There are subglacial lakes that have been sealed off for millions of years, ancient river systems now frozen in place, and vast mountain ranges like the Gamburtsev Mountains buried entirely under ice. These findings alone would be enough to call Antarctica one of the last great unexplored frontiers. But the real intrigue begins when magnetic mapping enters the picture. Scientists scanning the continent for gravitational and magnetic anomalies have detected areas where the readings don't align with normal geology. One of the most puzzling discoveries lies in Wilkes Land, an immense crater-shaped magnetic signature that shouldn't exist. It's too large, too deep, and too magnetically intense to fit known geological models. And it's not just a blip. It's been independently verified by multiple research teams using different satellite technologies. This anomaly suggests something unusual is buried deep under the ice. Some suggest it could be the result of a massive asteroid impact. Others whisper more extraordinary theories: artificial structures, remnants of a lost civilization, or evidence of Earth's forgotten past. While mainstream science treads carefully, even cautiously, it's clear the Wilkes Land magnetic anomaly has opened the door to speculation that once belonged solely to science fiction. The fact that so much of Antarctica is still unmapped, unmeasured, and largely untouched makes it the perfect canvas for both rigorous scientific inquiry and limitless imagination. And as technology improves, we're no longer limited to surface-level data. New methods like satellite radar, seismic imaging, and neutrino detection are now pushing deeper into the Antarctic crust, exposing anomalies that beg for explanation. Antarctica, once thought of as a lifeless, frozen void, has become a scientific goldmine, one that holds clues not just about Earth's past, but possibly about its future. And the strange magnetic discovery beneath Wilkes Land may be the key that unlocks an entirely new chapter in understanding what's really happening beneath all that ice. What is a magnetic anomaly? To understand why the strange magnetic readings under Antarctica are so shocking, we first need to explore what a magnetic anomaly actually is. The term may sound technical, but the concept is surprisingly straightforward once broken down. In simple terms, a magnetic anomaly occurs when there's a sudden, unexpected variation in the strength or direction of Earth's natural magnetic field in a specific location. These variations are usually caused by something unusual underground, something dense, metallic, or geologically different from its surroundings. The Earth's magnetic field is like an invisible shield surrounding the planet. It's generated deep inside the Earth's core, where molten iron and nickel create electric currents that act like a massive planetary dynamo. This magnetic field is essential to life. It protects us from harmful solar radiation, guides the migrations of birds and marine animals, and even allows compasses to work. It's one of the few things on Earth that's been stable over millions of years, until something disrupts it. When scientists measure the magnetic field, they're looking for patterns that should generally follow Earth's known geological structure. But when they encounter an area where the readings spike or dip far outside what's expected, that's when they know they've found a magnetic anomaly. It's like finding a fingerprint that doesn't belong at the scene of a crime. Something is off. Something is different. And it demands further investigation. To detect these magnetic signatures, scientists use magnetometers. These highly sensitive instruments can be mounted on satellites, aircraft, or used directly on the ground. They work by measuring the strength and direction of the magnetic field at any given location. On a map, the data from a magnetometer can show areas of unusually strong or weak magnetism, what appear visually as patches of high-intensity color. These areas often reveal the presence of dense rock formations, iron-rich materials, or massive underground structures that distort the natural flow of magnetic energy. Most magnetic anomalies are relatively small and easy to explain. They often point to iron ore deposits, fault lines, or even volcanic activity. For example, magnetic surveys have been used extensively in mining to locate valuable resources beneath Earth's surface. In many cases, these anomalies are simply a tool for better understanding local geology. But every once in a while, researchers come across a magnetic anomaly that doesn't fit the usual explanations. And that's exactly what's happening beneath Antarctica. The anomaly in Wilkes Land is different, not just in size, but in intensity and structure. It spans over 300 miles in width and is buried beneath nearly 2 miles of solid ice. Its magnetic signature is so strong that it was first picked up by NASA's GRACE satellites, which weren't even designed to look for magnetic disturbances. These satellites were meant to measure gravity changes, not magnetism. Yet the anomaly was so massive, so dense, that it affected both gravitational and magnetic readings. That's not something you see every day. This magnetic field disturbance doesn't match any known rock formations, metal deposits, or crustal features found elsewhere on the planet. It's far too large to be a natural ore body. It's too deep to be a volcano. And its magnetic intensity rivals that of some of the most significant impact sites in geological history. Yet there's no crater on the surface, no sign of devastation, no visible scar. Only a quiet, frozen landscape that looks perfectly ordinary on the outside while hiding something extraordinary underneath. The mystery only deepens when you compare the Wilkes Land anomaly to other famous magnetic anomalies around the world. For instance, the Kursk magnetic anomaly in Russia is one of the most powerful on the planet and is linked to enormous iron ore reserves. But the structure and location of the Antarctic anomaly don't match that profile. Then there's the Bangui anomaly in Central Africa, another magnetic disturbance of unknown origin. But even that doesn't come close in terms of how concealed and geophysically peculiar the Wilkes Land signal is. Some have proposed that the Antarctic anomaly could be the remnant of a long-lost asteroid impact, buried deep beneath ice and sediment over millions of years. Others speculate it could be a massive igneous intrusion, molten rock that rose from the mantle and cooled into a dense, metallic slab. And yet, neither theory fully explains the magnitude or shape of the magnetic readings. Something about this anomaly simply doesn't align with our current understanding of Earth's internal structure. That's why this particular magnetic anomaly is causing such a stir in the scientific community. It's not just an unexplained blip. It's a persistent, measurable disturbance that has now been confirmed by multiple datasets, from different sources, across several years. It's not going away, and it's not getting any less strange. When scientists find a magnetic anomaly of this scale, they don't ignore it. They know it could hold the key to a catastrophic event from Earth's ancient past, or a discovery that changes our entire view of what lies beneath us. And as more data rolls in, one thing becomes increasingly clear. This is no ordinary magnetic signature. This is something entirely different. And we're only beginning to understand what it really means. The Wilkes Land crater discovery in 2006, something extraordinary appeared in data transmitted from space. NASA's GRACE satellite mission, short for Gravity Recovery and Climate Experiment, was primarily designed to monitor changes in Earth's gravitational field. Its goal was to help scientists measure things like ice mass loss in Greenland and Antarctica, groundwater depletion, and subtle shifts in Earth's crust. But what GRACE revealed in Antarctica stunned the scientific world. While scanning beneath the eastern region of the continent known as Wilkes Land, the satellites detected a massive gravitational anomaly, indicating something incredibly dense hidden deep below the ice. At first, researchers weren't sure what they were looking at. But as they dug deeper into the data and combined it with magnetic field readings from earlier surveys, a chilling picture began to emerge. Beneath the ice, more than 500 miles inland from the Antarctic coast, lay a circular formation over 300 miles in diameter, an underground depression of immense scale and unusual magnetic intensity. To put that into perspective, that's more than twice the size of the Chicxulub crater in Mexico, which is widely believed to be the impact site of the asteroid that wiped out the dinosaurs. The Wilkes Land crater, as it came to be called, was unlike anything geologists had seen before. There was no visible scar on the surface of the ice, no sign of destruction or upheaval, yet the data told a different story. The anomaly was massive, deeply buried, and had a perfectly circular shape suggestive of a colossal impact. Some scientists began to ask the unthinkable: could this be the site of an ancient asteroid collision, one so large and so devastating that it reshaped the planet's magnetic structure? What made the Wilkes Land anomaly even more perplexing were the accompanying magnetic readings. Normally, the Earth's magnetic field in that region is fairly uniform. But in Wilkes Land, magnetometers detected a high concentration of magnetic energy centered within the circular depression. This wasn't a localized bump or dip. It was a sweeping, intense magnetic field that contradicted everything geologists expected from the underlying bedrock. The anomaly extended hundreds of miles and showed signs of extreme density, suggesting the presence of metallic materials or rock that had been radically altered by intense heat and pressure. This combination of magnetic and gravitational data immediately sparked comparisons to the Chicxulub crater, which lies beneath Mexico's Yucatan Peninsula. Like Wilkes Land, Chicxulub was initially detected not through visible observation, but through geophysical data. In that case, gravity mapping and magnetic studies pointed to a buried crater over 100 miles wide, now accepted by most of the scientific community as the site of the impact that triggered Earth's last mass extinction event, about 66 million years ago. The similarities were hard to ignore. Both craters are deeply buried, both show intense magnetic signatures, and both are linked to layers of geological disruption that can't be explained by natural plate movements alone. Yet there's one major difference. While Chicxulub sits near the surface, accessible to drilling and ocean-based research, the Wilkes Land crater is entombed beneath nearly 2 miles of solid Antarctic ice. This makes direct exploration incredibly difficult, expensive, and, for now, politically complicated due to the strict regulations governing the Antarctic continent. Despite the lack of physical access, the theory that Wilkes Land could be the result of an ancient asteroid impact continues to gain traction. Some geologists propose that this impact may have occurred as far back as 250 million years ago, potentially tying it to the Permian-Triassic extinction event, also known as the Great Dying. That event wiped out over 90% of all marine species and about 70% of terrestrial life, long before the age of dinosaurs. If the Wilkes Land anomaly is connected to that catastrophe, then it would not only rival Chicxulub in scale but exceed it in geological and historical significance. But not everyone is convinced the crater is the result of an asteroid. Some researchers argue that the anomaly could be a natural feature of the Earth's mantle, perhaps a superplume of magma that solidified into a dense mass millions of years ago. Others suggest it may be an ancient rift zone, formed when the supercontinent Gondwana broke apart. Yet neither explanation fully accounts for the perfect circular shape, the gravitational depression, and the extreme magnetic values observed in the region. There's something about the Wilkes Land crater that resists easy classification. One of the most fascinating aspects of this anomaly is that it remained completely hidden for millions of years, undetectable without modern satellite technology. Before Grace, the region was just another blank space on the Antarctic map, overlooked and unremarkable. But now, it's the focus of intense speculation, not just from geologists and planetary scientists, but from historians, conspiracy theorists, and even military analysts. Everyone wants to know what lies beneath that ice, and what it means for the history of our planet. The implications are vast. If this truly is an impact crater, it could rewrite everything we know about Earth's mass extinction timeline. It could add a new chapter to the story of how our planet evolved and how life was shaped by cosmic forces beyond our control. It might even hint at a previously unknown event that altered Earth's magnetic structure, possibly explaining other anomalies. For now, the Wilkes Land crater remains one of Earth's greatest buried secrets. The combination of satellite data, gravitational readings, and magnetic signatures all point to something massive and mysterious lurking beneath Antarctica's frozen surface. Whether it's an asteroid crater, an ancient geological scar, or something even stranger, this discovery has opened a door that cannot be closed. The next step is finding a way to peer beneath the ice, not just with data, but with our own eyes. And when that day comes, we may finally understand what made Wilkes Land one of the most geologically confusing and scientifically tantalizing regions on Earth. Ancient cataclysm or something else? The Wilkes Land anomaly continues to provoke heated debate not only among geologists but also among historians, theorists, and researchers exploring Earth's more enigmatic past. What if the explanation for this strange magnetic signal isn't just a natural impact crater or a dense rock formation, but something far older, more significant, and perhaps more controversial? Some scientists lean toward the asteroid theory, but others are beginning to consider an even more mysterious possibility, that this anomaly is a scar from an ancient cataclysmic event that predates our current understanding of human and planetary history. Massive impact events have reshaped Earth more than once. The most famous, of course, is the asteroid that struck the Yucatan Peninsula and created the Chicxulub crater. That event, around 66 million years ago, likely caused the extinction of nearly 75% of all species on the planet. But Chicxulub may not have been the only global disaster. The Permian-Triassic extinction, which wiped out over 90% of marine life and most terrestrial species, has long puzzled scientists. Its cause is still debated. Some believe it was due to volcanic activity or environmental collapse. But others now speculate that it could have been triggered by a massive impact, possibly in Antarctica, precisely where the Wilkes Land anomaly sits. The scale and characteristics of this magnetic anomaly suggest a force powerful enough to alter more than just the local geology. Could an asteroid or similar cosmic event have struck Antarctica millions of years ago and shifted Earth's magnetic field? Could it have caused a rapid movement of the poles, a phenomenon known as a geomagnetic reversal or even a pole shift? While pole reversals are known to occur naturally over geological time, some researchers argue that a sudden, large-scale impact could accelerate this process or even trigger it unexpectedly. The theory of pole shift is not new. It has circulated in both scientific and alternative circles for decades. It suggests that Earth's outer shell might have slipped over its inner layers, changing the planet's orientation. While mainstream science considers the mechanism unlikely to happen rapidly, new data on crustal displacement, along with the detection of anomalies like that in Wilkes Land, has reignited interest. If an asteroid impact occurred in that region with enough force, the resulting shockwave could have destabilized Earth's rotation temporarily, contributing to mass extinction, climate upheaval, or even the loss of entire ecosystems beneath what is now miles of ice. Adding further intrigue is the resurfacing of an old, controversial artifact, the Piri Reis map. Created in 1513 by Ottoman admiral and cartographer Piri Reis, this map has mystified researchers for years. What makes it so strange is that it appears to show the northern coastline of Antarctica not as it looks today, buried under ice, but as it would appear if the ice were gone. Even more fascinating, modern geological surveys confirm that the landmass beneath Antarctica's ice matches the contours drawn on the Piri Reis map with startling accuracy. This level of detail was supposedly impossible to know in the 16th century. So how could such a map exist? Some claim it's a coincidence, a misinterpretation of South America or some other landmass. Others suggest the map is based on older source materials, charts created by an ancient civilization with advanced cartographic knowledge that predates recorded history. If the Wilkes Land crater is connected to a cataclysmic event, could it have wiped out such a civilization, leaving only fragments behind? Could this anomaly be the buried ruins of an ancient city, a forgotten empire swallowed by ice, its magnetic footprint the last trace of what once was? This brings us into even more controversial territory, the theory that Antarctica was once home to a pre-Ice Age civilization. Though mainstream archaeology doesn't support this idea, there are growing numbers of researchers, authors, and independent scientists who believe that the frozen continent may have once supported life in a much warmer era. Geological records show that Antarctica wasn't always a frozen wasteland. During the Eocene period, roughly 50 million years ago, parts of the continent were covered in lush forests and teeming with diverse wildlife. More recently, about 12,000 years ago, the Earth entered the Younger Dryas, a sudden cooling period that some believe was triggered by another cosmic event. Could Antarctica have been habitable just before this freeze? Satellite scans, sonar mapping, and ground-penetrating radar have revealed structures beneath the Antarctic ice that defy explanation. Some researchers claim to have found linear formations, pyramid-like shapes, and organized geometries far too symmetrical to be natural. These claims are, of course, hotly contested, but they've gained traction online and in fringe scientific communities. The idea that Antarctica's magnetic anomaly could be connected to ancient architecture or long-lost technology buried beneath the ice is no longer just a wild conspiracy, it's a serious question being posed by those re-examining old evidence with new tools. There's also a growing belief that ancient civilizations might have had a deeper understanding of Earth's magnetism than we do today. Magnetic alignment appears in several ancient monuments around the globe, from the Great Pyramids of Egypt to stone circles in Britain and South America. These structures often align with magnetic north or incorporate geomagnetic properties into their design. If a civilization once existed in Antarctica, it's possible they too understood and harnessed magnetic forces. The intense anomaly detected in Wilkes Land might not be the result of an asteroid at all, but something artificial, constructed with a purpose we no longer understand. While mainstream science remains cautious, the mystery of Wilkes Land refuses to go away. Whether it's a remnant of a massive cosmic collision, a geological feature formed through natural processes, or the last footprint of a lost civilization, the fact remains: something is buried deep under the Antarctic ice that we cannot explain. The deeper we look, the more we find clues pointing to a past that is far more complex than textbooks would have us believe. As ice continues to melt and technology advances, we may get closer to the truth. Whether that truth confirms a violent asteroid impact, reveals a long-lost chapter in human history, or forces us to rethink the nature of Earth's magnetic behavior, one thing is certain. The Wilkes Land anomaly has already changed the way we see Antarctica, and it may soon change the way we see our entire past. Strange phenomena around the anomaly. The Wilkes Land magnetic anomaly isn't just a mysterious signature buried beneath the ice. It's surrounded by a series of bizarre and unsettling phenomena that have puzzled scientists, researchers, and expedition teams for years. This isn't just a quiet zone with strange satellite data. It's a region where things behave differently, where equipment malfunctions, instruments fail, and natural laws seem to bend just slightly enough to be noticed. These irregularities don't happen randomly. They consistently cluster around the same general area, right above the massive magnetic field disturbance first revealed by NASA's satellite data. One of the most frequently reported issues near the Wilkes Land region involves GPS failure. Modern expeditions rely heavily on global positioning systems for navigation, safety, and data recording. But in this part of East Antarctica, devices that function perfectly in other locations suddenly become unreliable. GPS signals weaken, shift unexpectedly, or disappear altogether. In multiple recorded instances, teams traveling near Wilkes Land have reported the coordinates drifting or changing without movement. In some cases, compasses begin to spin erratically, as if caught in an unseen vortex. This is particularly alarming given the hostile environment, where a loss of direction can quickly become life-threatening. While it's easy to dismiss such glitches as technical errors or the effects of polar weather, the pattern and consistency of these reports suggest something more. These are not one-off problems. They have been logged by multiple teams, from independent researchers to military-affiliated scientific missions. The malfunctions often occur in tight clusters, and always in proximity to the magnetic anomaly. If this was simply environmental interference, the disruptions would appear more randomly. Instead, they trace a disturbingly accurate circle around the area identified by satellite scans as magnetically abnormal. Beyond navigation issues, the region also presents unexplained variations in temperature and gravity. Although the Antarctic climate is extreme by default, certain pockets near Wilkes Land show temperature spikes that defy seasonal logic. Ground temperature readings taken in the middle of winter have shown local increases up to 10 degrees higher than surrounding areas, despite identical exposure to sunlight and similar terrain. These warm zones are not caused by surface conditions but seem to originate from below, possibly pointing to geothermal activity, or something deeper and less understood. Gravity readings have also raised questions. The GRACE satellites first identified a significant gravitational anomaly in Wilkes Land, indicating the presence of something exceptionally dense beneath the ice. But ground-based gravimeters used by expeditions have revealed fluctuating readings that don't match expected values. Gravity in this region seems to behave in waves, shifting subtly over time, almost as if something beneath the ice is either moving or emitting pulses of gravitational energy. While that idea may sound like science fiction, the raw data supports the claim. It's not an anomaly in isolation. It's part of a larger pattern that includes shifting magnetism, localized warmth, and navigational confusion. Then there's the seismic activity. Antarctica is not typically associated with earthquakes, but sensors placed across the continent to detect tremors from time to time. What's unusual about the Wilkes Land area is the type and frequency of the seismic signals. Instead of registering clear fault line tremors, researchers have documented shallow, rhythmic pulses, signals that don't conform to standard seismic behavior. These pulses seem to originate from beneath the anomaly and occur at intervals that are difficult to explain geologically. Some have proposed glacial movement as the cause, but even those theories fall short of explaining the consistency and strength of the signals. Several expeditions have attempted to get closer to the anomaly, both for scientific research and for geopolitical reasons. But many of these missions have encountered unexpected obstacles. One privately funded European team in the early 2000s had to abort their route after losing satellite communication for over 12 hours. They later reported severe magnetic interference, sudden weather shifts, and equipment failure that forced them to retreat before reaching their objective. Another joint Russian-American scientific collaboration reported the unexpected shutdown of seismic sensors while within proximity of the anomaly. Their instruments restarted only after the team had retreated a significant distance. Even more curiously, certain data from government-led expeditions remain classified. During the Cold War, both the Soviet Union and the United States conducted deep ice core drilling and remote sensing missions in Antarctica. While many results were published in peer-reviewed journals, specific segments of their magnetic mapping, especially those concerning East Antarctica, are conspicuously absent. This has led some to speculate that the anomaly may be considered of strategic interest and that nations may be sitting on more data than they are willing to share. Despite the secrecy, there have been rare instances where scientists who have visited the region have shared their personal accounts. One such geophysicist, who asked to remain anonymous, described the experience as deeply unsettling. According to him, the instruments he brought functioned perfectly at the start of the mission, but once the team entered the outer radius of the anomaly, equipment began to behave unpredictably. Data storage devices failed. Batteries drained faster than normal. Metal detectors gave false readings. He stated that it felt as though something under the ice was interfering with their entire toolkit, something powerful, constant, and unexplainable. Another researcher from a German climate study team reported a different kind of interference, this one biological. She claimed that during her time near the anomaly, she experienced sudden, intense vertigo and pressure in her ears, as though being affected by a powerful subsonic frequency. None of her teammates suffered the same symptoms, and medical tests revealed no underlying condition. Yet the symptoms persisted while in the area and disappeared completely once she left. This account mirrors others that suggest not just electromagnetic or gravitational interference, but perhaps even physiological effects caused by proximity to the anomaly. As more teams try to access Wilkes Land, the list of strange occurrences continues to grow. Whether it's navigation failures, gravity waves, or unexplained pulses from beneath the ice, the anomaly exerts a presence that goes beyond what can be easily measured or mapped. The more that science pushes into this hidden region, the more questions arise. The magnetic anomaly of Wilkes Land is not just a quiet spot on the radar. It is active, reactive, and deeply puzzling. Something in that part of the Earth seems to be disturbing our instruments, interfering with our senses, and maybe even affecting the people who venture too close. While no one has been able to say for certain what lies beneath the ice, the strange phenomena surrounding it suggest that the answer may be unlike anything we've ever discovered before. Government secrets and conspiracy theories. Antarctica has always been a land of mystery, but when you start to peel back the layers of official government involvement, that mystery deepens into something more unsettling. The question often asked by researchers, theorists, and even some in the scientific community is simple: why is so much of Antarctica off limits? It is the only continent on Earth governed by a collective international treaty that strictly limits military activity, economic development, and independent exploration. While the official reason is environmental preservation, others argue that the level of restriction hints at something else, something being deliberately concealed beneath the ice. Signed in 1959 and enforced since 1961, the Antarctic Treaty prohibits any nation from claiming territory or conducting military operations on the continent. It emphasizes peaceful scientific research and environmental protection. On the surface, it sounds noble. But if you look deeper, you'll find that large swaths of the continent are either inaccessible, under constant surveillance, or tightly controlled by a handful of major powers. Independent researchers often face insurmountable bureaucratic hurdles, while certain areas remain completely unexplored due to undefined but strictly enforced no-go zones. The Wilkes Land region, where the massive magnetic anomaly lies, is one such area that seems to attract more restrictions than answers. Historical precedent shows that Antarctica has long been of strategic interest to governments, particularly the United States. One of the most revealing examples is Project Iceworm. In the 1960s, under the guise of scientific research in Greenland, the US military initiated a top-secret plan to build nuclear missile launch sites hidden beneath the ice. Though Project Iceworm was eventually abandoned, it proved one key thing: ice-covered territories offer unique opportunities for hidden infrastructure, shielded from satellites and global scrutiny. If such a project was attempted in Greenland, it's not hard to imagine similar activities being considered, or even executed, in the vastly more secluded reaches of Antarctica. The history gets even stranger when you examine the persistent rumors surrounding Nazi interest in the continent during the 1930s and 1940s. Officially, Nazi Germany conducted a single expedition to a region they named New Swabia. But numerous post-war accounts and declassified intelligence documents suggest a more extensive operation. According to some of these sources, the Nazis established hidden bases, conducted experiments, and explored underground cave systems beneath the ice. While many historians dismiss these claims as conspiracy, they continue to circulate due to overlapping reports from post-war intelligence briefings, unexplained U-boat missions in the Southern Ocean, and the curious focus of Allied surveillance in that region even after the war had ended. One of the most significant and mysterious military expeditions in Antarctica's history was Operation Highjump in 1946. Led by Rear Admiral Richard E. Byrd, this massive U.S. Navy operation involved 13 ships, over 4,000 men, aircraft, helicopters, and months of preparation. Officially, the mission was to test equipment and train personnel under polar conditions. But many have questioned why such a large force was necessary for what was labeled a training mission. Even more suspicious was how quickly the operation was cut short. The official reason given was harsh weather, but Admiral Byrd's own interviews hinted at something far more ominous. In one now famous quote, he mentioned the possibility of flying objects that could move at incredible speeds, statements that have been interpreted as cryptic references to encounters with unknown technology. This leads to a question that continues to stir controversy. Is the Wilkes Land magnetic anomaly simply a natural geological formation, or could it be something else? Could it be the buried remains of ancient advanced technology, long forgotten and now entombed under miles of ice? Some fringe theorists even suggest it could be an intact structure, an alien craft, an underground base, or a remnant of a pre-human civilization that understood magnetism and energy in ways we do not. The magnetic intensity and gravitational distortion associated with the anomaly are so extreme, they rival only the most powerful technological or extraterrestrial interference theories offered by modern science fiction. Adding to the mystery are recently declassified CIA and Department of Defense documents that reference strategic interest zones in Antarctica. While most of the content is heavily redacted, a few unintentional disclosures confirm that military flights have been conducted over specific coordinates near Wilkes Land. One internal memo from the 1980s makes a vague reference to subsurface density irregularities of potential interest, and recommends further study using classified aerial instrumentation. Another partially unredacted document from a Joint Intelligence Committee simply refers to the region as a zone of persistent anomalous magnetic interference requiring multi-agency observation. Though the language is cryptic, the message is clear: someone is watching this area very closely, and not just for scientific curiosity. There are also reports from satellite operators of restricted data zones in Antarctica. In certain areas, again, especially near Wilkes Land, imaging resolution is noticeably reduced, data streams are cut short, or images appear to be missing from public archives. While this could be explained by technical limitations or environmental interference, similar disruptions are rare in other parts of the world with comparable conditions. When these interruptions consistently occur over an area already known for its magnetic and gravitational anomalies, questions arise that are hard to ignore. Some believe that these restrictions and intelligence efforts are a coordinated attempt to cover up something too disruptive for the public to process. Whether that's a massive asteroid impact, an advanced technological artifact, or something more abstract, like a gateway to a deeper understanding of Earth's electromagnetic structure, remains unclear. But the one thing that unites the disparate theories is the belief that Antarctica holds a secret, and that governments may know more than they are willing to admit. Despite the tight veil of secrecy, the cracks are beginning to show. Independent researchers armed with commercial satellite data, open-source radar imaging, and ground-penetrating tools are gradually assembling a clearer picture. And while the official explanations remain vague or silent, the patterns of activity speak louder than words. Countries continue to send research missions into the icy void. Military organizations maintain a watchful presence. And hidden beneath it all, the Wilkes Land magnetic anomaly pulses with a force that defies explanation. It's not hard to see why this has become the epicenter of so many conspiracy theories. In a world increasingly shaped by surveillance and control, the idea that an entire continent could be shielded from scrutiny feels too convenient. The data tells us something is there. The behavior of those in power suggests they don't want us to know what it is. And the closer we get to the truth, the more the story begins to sound less like fiction and more like a very real, very old secret frozen in time. New scientific breakthrough. The mystery surrounding the Wilkes Land anomaly has only deepened in recent years. as new scientific data continues to challenge established geological models. Between 2020 and 2025, a wave of technological advances in satellite imaging, radar scanning, and deep Earth tomography has produced the clearest and most comprehensive look yet beneath the Antarctic ice. And what these tools are revealing has surprised even the most seasoned researchers. What was once considered a dormant magnetic oddity has begun to show signs of dynamic change. The anomaly is not fading, it's intensifying. Recent radar scans from European and Japanese satellite networks have corroborated NASA's early GRACE satellite findings, but with far greater detail and resolution. These modern instruments have mapped not just the gravitational dips and magnetic waves, but also the structural formations hidden below the ice. What's now emerging is the outline of an immense, highly concentrated mass unlike anything typically found in continental crust. This mass is so dense, and its boundaries so sharply defined, that it cannot be easily explained by ordinary geological processes. Satellite scans from as recently as early 2025 show new electromagnetic emissions, suggesting that this is not just a static formation but something active, something still affecting the layers of Earth above it. In addition to these surface scans, deep Earth tomography has allowed geophysicists to create three-dimensional models of the subterranean landscape. This method uses seismic waves generated by earthquakes or artificial means to image the planet's interior, similar to how an ultrasound reveals structures inside the human body. When applied to the Wilkes Land anomaly, tomography revealed a solid object extending far deeper than previously thought. The density of this object exceeds known rock types commonly found in Earth's crust. This has led to speculation that the structure could be composed of ultra-dense material, possibly even metallic in nature. However, there's no evidence of iron ore formations or natural mineral deposits large enough to explain the scale of what's being detected. Adding to the urgency of understanding this phenomenon is the fact that the magnetic intensity of the anomaly appears to be growing. Since the original data was collected in 2006, repeated measurements have shown a gradual but undeniable increase in magnetic flux in the region. As of 2025, some scientists are reporting values that are up to 7% higher than the previous decade. In magnetic terms, that's significant. Earth's magnetic field is typically stable on a geological timescale. For a specific region to intensify so quickly suggests that some internal process is underway, and that it may be accelerating. The anomaly's behavior has reignited an old debate in the geological community. Could this be the result of a deep magma plume? Magma plumes are large, column-like upwellings of hot rock from the Earth's mantle. They can cause volcanic hotspots like those in Hawaii and Iceland. If a plume were rising beneath Wilkes Land, it could explain the increased heat, the gravitational distortions, and the localized magnetic intensification. Some researchers argue that we're simply witnessing the early signs of a mantle plume preparing to breach the crust, which could one day trigger volcanic activity or even continental uplift in Antarctica. But the plume theory doesn't sit well with everyone. Critics point out that there is no accompanying seismic pattern typically seen in known hotspot zones. There are no swarms of micro-earthquakes, no evidence of thermal melting near the crust, and no visible venting or surface deformation. What's more, the shape and density of the anomaly don't match any documented magma structure. Instead of a narrow, diffused vertical column, the anomaly appears to be flat-bottomed, angular, and sharply outlined, traits more consistent with solid, constructed objects than with geological formations. This divergence in interpretation has split the scientific community into two distinct camps. On one side are the geologists who argue that all anomalies can be explained through natural processes if we simply collect enough data. To them, the Wilkes landmass may be a relic of an ancient tectonic collision, a concentration of heavy minerals, or an unknown type of geological feature yet to be fully classified. On the other side are the researchers and independent theorists who believe that the current models of Earth's interior are insufficient to explain what is being observed. They point to the structure's symmetry, its electromagnetic behavior, and the increase in intensity over time as signs of something beyond standard Earth geology. The anomaly also presents a communications mystery. Satellite transmissions in the vicinity have begun to show unusual signal scattering, which some engineers believe may be linked to electromagnetic interference. Though no conclusive evidence ties this directly to the anomaly, the timing and location are hard to ignore. These disturbances are not yet strong enough to disrupt global communications, but they are persistent and localized. That persistence raises an important question. Is the anomaly generating its own field, or is it interacting with Earth's magnetic field in a way we don't yet understand? Even more compelling is the hypothesis that what we're seeing may be the buried remnants of an artificial structure, perhaps not one built by humans as we know them, but by some prior, unknown civilization with knowledge of electromagnetism far beyond our own. While such theories remain outside mainstream acceptance, the mounting data is creating space for their consideration. The fact that multiple countries are investing heavily in remote sensing and expedition planning focused specifically on Wilkes Land adds to the speculation. If nothing were there but old rock and ice, why devote such concentrated scientific effort, and why restrict access? As of 2025, a multinational team is preparing to launch a new series of autonomous drilling probes, designed to melt through the ice and relay data in real time. These robotic explorers are scheduled to reach within a few hundred meters of the anomaly's surface by late next year. If successful, they could return the first direct physical evidence of what lies buried beneath the ice. Whether they find rare geological material, remnants of an ancient catastrophe, or signs of an unnatural structure remains to be seen. But one thing is already certain: the Wilkes Land anomaly is not a static mystery. It is evolving. The next few years may be crucial. If the anomaly's intensity continues to rise, and if its magnetic field begins to affect global systems, it could force a reassessment of Earth's internal dynamics. We may have to revisit what we think we know about the stability of the planet's core, the consistency of its magnetic shield, and the possibility that somewhere deep in our prehistory, something, or someone, left behind a mark on Earth that we are only just beginning to notice. Future expeditions and what lies ahead. the mystery of the Wilkes Land anomaly has reached a tipping point. For decades, data gathered from satellites, ground scans, and seismic readings have painted a picture of something extraordinary lying beneath the Antarctic ice. But now, the focus is shifting from observation to direct exploration. In the coming years, a series of international scientific collaborations are set to launch a new generation of expeditions aimed at penetrating the frozen layers above the anomaly and uncovering the truth about what lies below. These missions are not just about solving a geological puzzle. They may fundamentally alter our understanding of Earth's history, climate, and magnetic behavior. Among the most anticipated efforts is a joint initiative involving research teams from the United States, Japan, Germany, and Australia. This multi-agency project will deploy autonomous drilling platforms capable of melting through several kilometers of ice with precision-guided technology. These advanced drills are designed to avoid contamination, protect fragile ice core records, and collect samples from areas just above the magnetic anomaly. The drilling process will be monitored in real time using AI-assisted systems that adjust trajectory and depth based on live feedback from internal sensors. The goal is to get closer than ever before to the dense structure responsible for the magnetic and gravitational disturbances without triggering environmental instability or violating Antarctic treaty protocols. One of the most cutting-edge tools being deployed in this effort is neutrino detection. Neutrinos are nearly massless particles that pass through matter with almost no interaction. Because of their unique properties, they can be used to scan through massive layers of rock and ice, revealing hidden features invisible to traditional radar or seismic methods. By placing neutrino detectors around the perimeter of the anomaly and analyzing the flow of these particles, scientists hope to build a clearer image of the object's internal composition. If successful, this method could provide a three-dimensional map of the buried mass and help determine whether it is geological, metallic, or something entirely unknown. Artificial intelligence will also play a central role in these expeditions. From terrain mapping and anomaly detection to real-time decision-making and predictive modeling, AI will enable researchers to interpret vast datasets more quickly and with greater accuracy than ever before. Machine learning algorithms will be trained on known geological formations to recognize patterns and outliers in the Wilkes Land region. Any irregularities, symmetrical formations, unusual density signatures, or unexplained electromagnetic behavior will be flagged for deeper investigation. AI models are already being used to simulate the impact of possible discoveries, from how a massive metallic object would affect Earth's magnetic field to how ancient biological material might be preserved in subglacial lakes and cavities. Speculation about what these missions might uncover ranges from the conservative to the truly extraordinary. At the most basic level, researchers may find dense rock formations that challenge current geological models, helping to refine our understanding of plate tectonics and mantle dynamics. But more speculative theories persist. If the anomaly turns out to contain high concentrations of metal, particularly alloys not commonly found in the Earth's crust, it could suggest either a previously unknown natural process, or something artificial. Some even believe the mass could contain remnants of advanced tools, machinery, or architectural structures buried and preserved by millennia of ice and time. Another possibility is the discovery of ancient biological material. In recent years, scientists have found microbes and life forms in other subglacial Antarctic lakes, organisms that have survived for hundreds of thousands of years in total darkness. If similar organisms or even fossils are found near the anomaly, it could shed light on a lost chapter of Earth's evolutionary history. Such a discovery would have profound implications, not just for biology, but for theories about Earth's climate cycles, extinction events, and the resilience of life in extreme environments. The implications of exploring the Wilkes Land anomaly extend far beyond scientific curiosity. If the anomaly proves to be an ancient impact site, it could help pinpoint the cause of past extinction events and improve predictive models for future planetary threats. If it turns out to be a natural but unexplained magnetic formation, it could advance our knowledge of Earth's core dynamics and magnetic field generation, critical information in an age where magnetic pole shifts are accelerating and satellite infrastructure is increasingly vulnerable to geomagnetic disruption. And if the structure is not natural at all, if it contains evidence of intelligent design or unknown technology, then the implications become truly staggering. It would force a global reassessment of human history, the origins of civilization, and the possibility of contact or influence by pre-human intelligence. It would also raise pressing questions about why such knowledge has remained hidden and what else may be waiting beneath the ice of the world's least understood continent. Regardless of what is ultimately found, these expeditions mark a turning point in Antarctic exploration. The age of passive observation is giving way to active, targeted investigation powered by a fusion of artificial intelligence, particle physics, and international cooperation. In the next few years, humanity will reach deeper into the icy abyss of Wilkes Land than ever before. And with each layer of ice that is removed, with each new scan and sample, the veil over one of Earth's greatest mysteries grows thinner. What we discover may confirm the theories of the past. Or it may reveal something no one expected. Either way, the countdown has begun. The world is watching, the ice is shifting, and beneath it all, the anomaly waits. For decades, Antarctica has remained the most mysterious and least explored region on Earth. But nothing within its icy expanse has stirred more curiosity, more speculation, or more scientific and political tension than the massive magnetic anomaly hidden beneath the ice of Wilkes Land. What began as an unusual reading from NASA's GRACE satellite has grown into one of the most complex and baffling discoveries in modern geology. From unexplained gravitational shifts to electromagnetic interference, from whispers of ancient civilizations to the latest breakthroughs in AI-driven terrain mapping, every layer of this mystery seems to reveal something even stranger beneath it. We've seen how this anomaly spans over 300 miles across and sits half a mile beneath the ice. We've looked at theories that range from ancient asteroid impacts to dense geological intrusions, from the possibility of advanced artificial structures to remnants of pre-Ice Age civilizations. The scientific community remains divided. Some insist it's a natural phenomenon, albeit one we do not yet fully understand. Others remain open to more radical explanations, especially as the data continues to pile up and the anomaly shows signs of activity rather than dormancy. One thing is now undeniable. Something is down there, and it doesn't behave like anything else on Earth. But this mystery isn't just a scientific curiosity. It matters. Understanding what lies beneath Antarctica's ice could have far-reaching implications for humanity. It might help us decode Earth's magnetic field and its connection to climate cycles. It might help us understand how extinction events are triggered and whether such an event could ever happen again. It might even point to entirely new forces or events in our planet's past that current science cannot yet explain. The question of what lies beneath Wilkes Land isn't just about geology, it's about the story of Earth itself. It's also about how that story is told, and who gets to tell it. Time and again, we've seen how information about Antarctica is tightly controlled. Access is restricted. Raw data is sometimes withheld or classified. And even the language used in scientific and military reports often feels carefully measured. This has led to a growing sense that there's a line between science and secrecy, a thin, uneasy boundary where curiosity meets silence. Why are certain areas off-limits? Why are independent researchers discouraged from going too far? And why are governments investing so heavily in a piece of frozen land that, on the surface, offers no strategic value? The answers may be more complex than we think. Or they may be surprisingly simple. Perhaps it's all about science. Perhaps it's about national interest, or the fear of revealing something that challenges everything we thought we knew. Or perhaps it's about something more, something still hidden, not just beneath ice, but beneath layers of institutional reluctance to face the